Section 15B.1, question number 1, page 364. This question is asking us to find the composite function g of f of x, given the two functions. In part A of question 1, we've got g of x is x squared and f of x is 2x plus 7. So g of f of x, we use g of x first, which is this function squared, and if f of x is being substituted in for x of g of x, then we substitute 2x plus 7 into that, so we get 2x plus 7 all squared for g of f of x. Part B, g of x is 2x plus 7, and f of x is x squared, so the roles have reversed now for g of f of x and f of x from part A. So g of f of x, in this case, so we're substituting f of x into g of x, so we've got 2 quantity plus 7, and f of x is substituted into g of x, so the x squared goes in here. So we end up getting 2x squared plus 7, as opposed to, in part A, 2x plus 7 all squared. Part C, g of x is root x, and f of x is 3 minus 4x. So g of f of x, so we're starting out with the square root function, the radical, and then 3 minus 4 of x, or 3 minus 4x goes in for x, gets substituted in for x of g of x, so we end up getting the root of 3 minus 4x. Part D, g of x now is 3 minus 4x, and f of x is root x. So when you find g of f of x, we've got 3 minus 4, and now we're substituting root x into the x for g of x, so we get root x in this case, so we get 3 minus 4 root x, which is different than root 3 minus 4x from part C. Moving on to part E, g of x is given as 2 over x, and f of x is x squared plus 3. So g of f of x, well, f of x is getting substituted into the x of g of x, so we've got 2 over x squared plus 3. And then for part F, again a little role reversal, g of x equals x squared plus 3, and f of x equals 2 over x. Again, f of x gets substituted in for g of x, into the x for g of x, so we've got that part of g of x, and then f of x gets substituted in here, so 2 over x all squared plus 3, so we can simplify that a little bit to get 4 over x squared plus 3.